Hey guys, welcome to Code Decode. For this mock interview, we have Akshat with us and he will be sharing his preparation and insight on how we can design a video sharing platform like YouTube. So let's get started and see how we can design the YouTube. That will be our HLD part initially, and then subsequently we'll be covering the LLD part too. So let's get started. And also, if you guys want to be the part of this mock interview series, just add your details in the Google form given in the description and we will reach out to you as soon as possible. Let's get started. Hi Akshat, how are you?
Hi Ashi, I'm doing good. How about you?
Thank you for asking. I'm good too. Today we have Akshat with us, guys. We are going to shoot a mock interview for the system design. So let's get started, Akshat, whenever you are comfortable.
Sure, let's get started.
Perfect. I'll be transitioning. Can you see the screen now?
Yes, I can see the screen now. All right.
Perfect. Okay. So Akshat, can we discuss something or system design on, say, YouTube itself? Is it comfortable for you?
Yeah, let's get started.
Perfect.
All right.
So I'll give a brief introduction about this platform. This is the place where you can have your diagrams created. This is the plus sign. You can draw anything, any shape that you want, a circle, rectangle, everything is here. These are the things that is common ones. Also, you can have any cloud items also. Say suppose you have cloud provider icons here. So if you want to use Azure, AWS, anything, Kubernetes, anything that you want, you can always insert an item. And if not very sure, just try to type it here. Like for example, I want Kubernetes. So you can have the Kubernetes logo like this. So you can use anything that you want to use if you need. And you can draw the system design here, and I'll be putting my functional and non-functional requirements here if you're okay with it. Works?
Sure. That sounds good to me. All right. So what kind of features are we looking at for YouTube, Yashi? If I just quickly maybe jot down the basic functional and non-functional requirements like you say, right?
Perfect.
All right, let's get started.
Perfect.
Go ahead,
so
please.
I would say that we should, we'll start with very simple things. We should be able to upload a video. We should be able to browse or watch the video or stream or basically video.
All right. So browse and watch a video. So I think let's keep it diversified in terms of browsing a video being a search functionality over here. And then we'll be looking at watching a videos in terms of you'll be able to play videos as such, right?
Okay.
And then what else are we looking at in terms of YouTube?
Then I would say that we should be able to have something called as analytics that can be given to the users, the creators. So creators uploads a video, right? They should be able to do it from the analytics part also. They should see how their videos are performing. Then how about they should be able to watch and upload the videos both from a mobile application, from a browser, from TV, anything, any possibility with which is having a proper internet availability.
Right, makes sense. So we're looking at multi-device support in terms of both network and as well as, of course, the device in itself being an iPad maybe or a mobile phone or a computer, laptop as such, right?
Correct.
What about recommendations? Are we
I was about to say that. Yes. So what I would say is there's a feed page where you are recommended that you want to watch this video or not. So if this is a possibility, it will be a good to have.
Makes sense. So we'll have a feed page and implying for recommendations in terms of...
Also, there's one more good to have. That is comments. Like, share, subscribe, all those things. These are all good to have. If you can have it, it's great.
User comments and maybe descriptions and different likes and things like that, right?
Correct. Descriptions and this comes in metadata. So
so we can keep it like likes and user comments,
share,
likes
subscribe.
And
also, since you have given me a pointer, you can also have a good to have as metadata. You can store all the metadata of these videos.
Right. So that will be taken care of already because we're dealing with uploading the video in terms of not only the picture part of it, but of course, some other metadata has to be a part of the video itself. Because on the basis of that, only we'll be dealing with browsing and watching other things and the analytics come into the picture. All right. I think these are good enough functional requirements, Yashi.
One thing I would be requiring here is while you are uploading the video, not just audio, video, but also the metadata has to be stored somewhere. So that on the basis of that, recommendations can be given.
Makes sense. So we will be taking care of the metadata aspect in this scenario. Hope that sounds fine.
Sounds great.
Okay.
Then I want some non-functional requirements also here.
Let's talk about the non-functional requirements. So YouTube is a highly available application. So we of course have to take care of that over here.
Yes.
We have to ensure that we are dealing with partition tolerance as well, because we want to ensure that whenever some node goes down, we want the users to be able to access the resources available online. So if it's a microservice kind of an architecture, if one node goes down, we should be able to adhere to give the data back to the users as such overall. Speaking of consistency, I think we can live with eventual consistency on YouTube, because it's something like if a person is trying to watch a video, unless and until it is a very highly demanded sort of a trailer maybe, or some sort of highly demanded video, I think we can live with eventual consistency of a gap of maybe with about 2 or 3 or maybe 5 minutes at the max. So we can compromise a little bit. Yeah. So you can strive for eventual consistency over here. Other than that, what kind of users are we looking at? What is the scale of users we're looking at?
So if you talk about numbers, what I have found is that the active users currently is around 2 billion and number of videos watched around is like 5 billions per day.
Okay. So 5 billions, sorry.
So if what you can do is, you can reduce this number and you make the estimations as per your requirement. But this is something which is actually happening today in the real world with YouTube.
Mm-hmm. So actually,
you can make it.
Yeah, that's okay. 5 billion users per day is a bit too much, but I think we can. I think it's about 5 million from what I remember last time.
It's number of videos watched.
Okay, so can we try answering this in terms of daily active users actually?
No problem.
Right.
Actually,
so I can strive to have
users. I would say that these are the number of videos watched. So one user can watch 10 videos also. So this is a very high number for daily users.
Right. Number of videos watched will make more sense.
Yeah.
That is going to be 5 billion. I think a better metric here is going to be daily active users on YouTube. So I think we can live with DAUs as such and call them as maybe 5 million users is what I remember the last time I discussed about it. And if we can assume that user per user video data could be around about, let's say, 5 videos per user, right?
We can assume that, yes.
Yeah. And we can say that out of these 5 million daily active users, we are dealing with about 10% people who upload videos. So essentially, I'm looking at two different kind of flows, right? The creators, basically. So there are going to be two segregated roles over here. One is, of course, going to be for the folks who are watching the videos. And the second is going to be for the folks who are uploading the videos, right? And we can also assume that the average video size, could be somewhere around about, let's say, 300 MBs, because we're dealing with around about maybe, let's say, 15 to 20 minutes of video size per average, I would say. And a 15-minute long video, if you're dealing with, let's say, 1080p's of pure HD content, then it basically implies somewhere around about 120 FPS. And one frame could be roughly around about, I guess, not more than 1 MB or 2 MBs, right?
Okay.
So
we're
dealing with, so roughly I'm assuming that this video size is supposedly 300 MBs. That's the average video size in that context. So if we just do a couple of back of the envelope estimation over here, we can say that the total daily storage we're looking at, this is going to be 5 million times 10% of 300 MBs, because 5 million total number of users and 10% of that, and into 300 MBs of data is what we're looking at per video. So this actually comes out to be as 5 into 3 would be 15, and 10% of that is going to be 1500, so 150 terabytes of data. So this is actually a lot of data, now that I think about it. So we'll have to account for this in this scenario. Okay. Also, because it's YouTube and we would want the latency to be as low as possible to the users, because it's like a very widely, a widely used application over all the world, we'll have to account for the CDN cost as well over here. Nice. So when cloud CDN serves a video, we would want to charge the amount of data which is getting transferred out of CDN. So I think we can live with Amazon CDN, I would say, which is a CloudFront CDN. And if I assume that 100% of the traffic is served from, let's say, the US, because that's the headquarter of the video, the average cost per GB per GB is nearly about I would say $0.5 per GB in that sense. So I think it's kind of like side drilling a little bit to the cost part of it, but this is the back of the estimation we are looking at over here.
Okay.
So for simplicity, if I just try to calculate the cost of video streaming, I would want to go in this particular direction because we're going with the CDN perspective over here. Now, you also mentioned that we are essentially talking about 5 million daily active users watching 5 videos per day, right?
Yep.
So if I talk about the per day metrics in this case, I can see that 5 million multiplied by 5 videos multiplied by 300 MB, so that will be 0.3 GBs into 0.02. That would be nearly about 150,000. Just to let me check.
25.
That's the cost basically. So no, my bad. 0.05, right? My bad.
Okay.
This is the $150,000 basically per day. $150K per day, which is the total cost estimated for the CDN over here. Okay. So we'll have to play around on the front of what kind of what kind of demography are we looking at, and based on that we can discuss on the CDN part in case if that's required.
So I would say I'll consider it as cost optimization that I'll be requiring during the non-functional.
Makes sense. Yeah, perfect. I would try to coin this as
because this is
cost
too
optimization
much for a place.
Yeah, makes sense. Okay, so I think this is good enough for a non-functional requirement basis.
I would require a few more things if you can.
Sure.
It's good to have.
Sure.
If you can, it will be great. So there is also something I need to have the scalability part, because sometimes YouTube is bombarded with a lot of things. Sometimes when there is like holidays, nobody's watching any education types of videos there. Some of the pods will have less of traffic.
Right. Makes sense. So from the scalability perspective, I would say the daily active users from 5 million can go to, let's say, maybe 10 million.
Okay, consider
just
that.
like doubling the numbers, right?
Yeah, no problem.
So in that case, we will have to account for the fact that we're looking at a daily storage of 300 terabytes of data. Even if I go extremely ahead of it, and let's say I'll do a 3x sort of a scale, I would still be looking at around 450 terabytes of data. That's my daily storage required, basically.
You should be able to come back, because it's not something you can have it every time. So scalability has to be in and out both.
So we're kind of looking at an auto scalable solution overall.
Yes.
So we can use any of the Amazon based techniques to be able to do that, like whatever kind of pods we're looking at. Auto scalable pods would imply we're spawning more pods as and when the traffic is increasing, and when the traffic is low, we can scale it down and restrict ourselves to maybe maintaining only a couple of lesser pods than the higher times actually. So this way we can auto scale the solution as and when time permits, in terms of more and more users come into the picture. And because, of course, we're talking about scalability, so we have to account for the replication perspective of the database as well. So by default, I can think of 3x replication. That's the standard process in terms of the microservice architectures. So we can think of like whatever the total data storage is coming out to be, which is like 450 TBs in case of very, very high storage values. 3 times of this would be roughly around about 1.5 petabytes of data, right? So 1.5 petabytes of data over here. Okay. I think this is a good enough scale for us to maintain in terms of YouTube overall, I would say.
Perfect. Also, how about the fault tolerance and error handlings? Because there's a lot of scope of errors happening in upload and viewing, right?
Right. So basically, when it comes to upload, let's talk about 2 flows over here. So first flow is going to be for the one wherein the user is trying to upload a video. Fault tolerance in this as such would imply the fact that I'm trying to upload a video and all of a sudden there was a network issue. So I was not able to upload the video perfectly. So we can add some checkpoints in terms of 300, like 300 MBs of data is not that much actually. So uploading 300 MBs on a cloud storage would imply that let's say if there's a failure in this upload process, I can just ask the person to upload the video one more time with like a graceful termination. That could be one way to deal with the situation. Second way is that, let's say I'm uploading the file in batches or chunks, for example. So in that case, right. So in that case, I can have certain checksums allocated for like splitter of a video, splitter service or something like that could be implemented on a video. And that is going to process the video in separate chunks and then store them on different bit rates as well. So it's an interesting thought actually, because we're dealing with multiple kind of networks, we're dealing with multiple kind of devices overall. So we have to ensure that the video is split across multiple different streaming, to be able to adhere to multiple different streaming bit rates. We have to ensure that the video is present in multiple different resolutions.
Perfect.
And we can't really allow the user to wait for this process to happen. So this is like a backend service which will be able to do that. If I kind of deep dive a little bit into it, so what YouTube or Netflix or all of these streaming services do is they have a splitter service like I discussed initially. And they have multiple codecs along which this video is getting split across multiple bit rates. So you can imagine that if you're uploading maybe a 1080p video, not every device or every network will be able to stream that. So because of codec value being limited down to 1080p, 720p, 480p, 360p, and so on and so forth, we can have a parallelization happening at the backend, which is taking one single video of that 300 MBs and then storing them on multiple bit rates upon the codec value onto some sort of a database to adhere to the fact that if my network latency is if my network is not that great, my download speed is a little less, maybe, for example. So I would not want to show 1080p video on that. I would probably go for a 720p video or a 480p video in that scenario. Perfect. So that's the splitter service workflow eventually over here, which comes automatically. That should be done automatically, obviously. Perfect. So the other flow is going to be the views part, wherein the person is trying to view the video. So if you're dealing with like very large videos, for example, let's say generally the videos which are having a total time frame of more than 1 hour, for example, I would not want to just give the entire 1 hour video content directly to the user. I would rather split it into batches such that I would know that from 1 minute to 10 minutes, there's a certain part which has been loaded. And once that part has been completed or about to be completed, the second part starts loading automatically for a more seamless experience. That way, I can also encounter for the part that in case my network latency goes very, very high, which means my network bitrate has become very small, very less. So in that case, I would not continue flowing with a 1080p video thing over there. I would rather give maybe like a 720p or a 480p on the back of the network overall. Because any which way, all the things are getting stored onto my CDN, right? So we can work with that. So I think we can handle the part of multiple network streamings. Right. So on the basis of that, we can work with the use perspective of this. Okay. Is this all good so far?
Yes. So far so good. Also, how about suppose I am uploading a video, and since you are using a splitter service, now you are splitting the video in chunks and you are uploading it. So one is uploaded, the second is uploaded, the third is down, and fourth is uploaded. So how would you make sure that it's, because what happens is if multiple times a particular chunk is uploaded, you will see the same chunk twice. Or else what happens is if one of the chunk in between is left to be uploaded, how would you handle such situations?
Right. So in that case, we can basically have checksums associated for every chunk which passes by, right? Like it's a sequential order of the video which is getting transferred overall. Correct. So let's say if I have a video of 300 MBs, I split them under 10 different chunks of 30 MBs each. I will exactly know that which chunk is getting uploaded and which is not getting uploaded. Correct. So for example, if I talk about 10 chunks, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's say I was able to upload the first 3 chunks at ease, but somehow I skipped this part. Correct. And then I started uploading the remaining ones out of 4, 5, like 5, 6, 7, and so on and so forth. So by the end of it, I should be getting some sort of a HMAC value indicating that is the video completely uploaded or not with a sequence of packets which are getting delivered. And I can simply decode in terms of which particular chunk was not able to get uploaded in the sequential flow of numbers. So I can again focus on only that part and then get that thing uploaded by the input which has been given by the user overall.
Okay, so during upload, there is a temporary location where the data is getting uploaded, right? So will you ask the user to upload it again if that a single chunk is not there? Because initially we have discussed that if there is a upload failure, we would ask the user to upload it again completely. So will that help us, or we will be storing at a temporary location? We will do it on our own. How would you approach that?
So we would not want the user to be doing this thing multiple times because it would be a bad user experience.
Correct.
What I would recommend is that we would probably store it to some sort of a temporary storage. And once we have put this up on the temporary storage at the backend service where Splitter runs and it kind of strips down the video with different codec formats and bitrate formats. At that point of time, we can check if it is actually a complete video there or not. If it is not, then we can specifically go back to the Splitter service and locate that pinpointed chunk which is not getting uploaded in the first place, and then copy it down to the actual location whichever needs to be.
Perfect. So this sounds good to me, that we don't have to make the user upload the same video again and again. We will be doing it on our own. We will be handling it on our own using some temporary location where we are going to store it for some time till the upload is completed.
That's right.
And after that, we will be removing it, right?
Yes, after that we will be removing it, of course.
Okay. So I would require some in-depth on how would you do that once we are into the system.
Sure, makes sense. So I think for now this is sufficient information for us to begin with the.
Yeah, this is more than
all right. So let's get to the.
It's upon you, but this much description sounds good to me.
Okay, perfect, right? So let's get down to the uploading part of it. Like I said, there'll be 2 floors. We'll discuss both the floors in detail. So let's get to the uploading part of it. So let's say, okay, I'm supposed to.
I'll help you. What do you want?
Oh, that's okay. I'll just was making the text to be a little smaller. Okay, no worries, I got that. So let's say I want to talk about the upload flow. So there are multiple users who are trying to upload this video. It could be coming from a from a TV maybe, or a laptop maybe, or whatever different devices which occur over here. So I'll need some sort of a load balancer first of all to be able to deal with this thing, right? Like where exactly to which particular service am I trying to put forward the request to? So I'll have to have a load balancer over here. Then there are going to be like multiple API servers over here across which my exploration is going to happen. Okay. And then, so I'm just going to put an API server.
Okay.
Across the API server, I could be having, like, let's say metadata management. You were talking about the video metadata thing, right? So we could be having like a metadata cache. And this is my metadata DB, which is storing all that metadata related information. Okay. And I can say that from the API server, it is going split across both these ends actually. Perfect. So there is this. And then I can say that once the upload thing has been completed in terms of the metadata cache I'm holding and the metadata DB I'm holding, there could be some sort of like a completion handler which will indicate the job has been completed perfectly or not. So completion handler, which is obviously going to interact with both my metadata DB and metadata cache just to comprehend if the task has been completed or not. Right? Okay. So we can live with this part. Nope. Now, once it is done, there's going to be some sort of a completion queue, which will try to understand that has the job been completed or not. So I'm just going to write a completion queue over here, which will be always reading my completion handler if a particular task has been completed or not. And then finally we can, if it's like could be an Apache stream maybe, which is trying to just continuously read onto that particular part. And now there's going to be a transcoding server. Like I said, multiple bit rates have to be accounted for in that factor, right? So that's my transcoding server, which is now will be reading from the completion queue what the job or the upload part has been successfully completed or not. And on the basis of that, the Splitter service is going to run inside this transcoding server to basically take the video and multiply with different bit rates and store them on different codec values and stuff like that. Finally, we can say that whatever the original storage was across on which the user was trying to upload the video. So if I just make another box over here, call this as like my original storage, the temporary storage, rather I should correlate with the discussion that we were having over here. So this original storage is the place from where we will have to copy down the content from the into the transcoding server over here. So I think this would be a better box for this.
Can we talk about what this original storage should be for your videos?
Sure. It could be a blob storage. So simple S3 would do.
Perfect. Okay.
So just a second. Okay, yeah, this sounds good. And then finally, we have done, once we have gotten the different bit rates on different codec values for the under the transcoding server, we can offset it to another transcoded storage and finally to the CDN. So we can say another like maybe S3 on which the transcoding server is putting down to the values.
Okay.
And then finally from this S3, we can pass it down to the CDNs from which
Okay.
people will be able to view everything eventually thereafter. This is going to be the flow for uploading the videos.
Okay. So you said that original server should be something like a blob storage, like
Yeah.
S3. And so suppose transcoding server is something who is going to store it in multiple P's, right? Suppose 1080, 520, and these types of different types of encryptions. So how would you store? Are you going to store each one in different ways? How would you do that?
So let me walk you through the flow of how exactly is this happening, right? So we
Okay.
can say the users upload something to the original storage, like a
Okay.
simple blob storage or S3 or Google Cloud or something like that.
Okay.
Then the transcoding servers fetch the videos from the original storage and then they start their encoding,
Okay.
right?
Okay.
So once the storing is complete, we now are doing these two steps in parallel, which are basically transcoding the videos that are to be sent overall to the transcoded storage over here. So we can say once the transcoding part has been completed, the following steps are executed in parallel, which would be basically that I'm trying to send the transcoded videos to the storage, of course, and the transcoded videos are further distributed to the CDN.
Okay. Okay, so your
Right?
one video, and suppose I have 10 ways to transcript it. So what I would do is transcode it. So what I'll do is I'll store 10 different chunks. That's how, for the same
Yes.
original video.
Yes, of course. We have to do that because, like I said, it has to be a very highly available thing, right? So to make sure that the video is ready at the disposal of the user, so we can start sending out that data immediately thereafter. So the completion handler, the completion handler part comes into the play. So these are basically a bunch of worker nodes that will continuously pull from the event queue that we're maintaining over here, the completion queue. So you can say that these worker nodes, once we can say the metadata cache and metadata database have been completely populated from the API servers, the completion queue will then give like a signal to the transcoding server that this particular job has been completed, start pushing the data to the CDNs immediately thereafter.
Okay. One question here. So you're storing some metadata to this DB. So what can this DB be?
Sure. So this database has to be a NoSQL DB because it's like a very wide column sort of a thing. It could be description. It could be like what particular channel is the video coming from. It could be how what users are we trying to target in that sense. It could be like all the sort of backend things which people generally put up on YouTube videos. I'm not too sure because I've never actually uploaded a YouTube video. But whatever the corresponding details there might be, we can put them up into a NoSQL kind of a database, from what I can understand.
How about, can we think about the relational ones? So when you upload a video, I'll tell you, there is a description, there is a title, there is a text, there is a thumbnail, and that's it. So while uploading, you have few metadatas only. So why are we trying to move towards Mongo?
I was under the impression that it's like a widely changing sort of a thing. It's a dynamically changing metadata. Right.
Content do change. So my description can be different from your description, but description will remain a description.
So I think if the attributes of the metadata remains the same, then we can live with a SQL over here. So instead of maintaining a NoSQL, in case the attributes change, then we have to think of something dynamic in nature. But if there's a guarantee that the metadata fields across which the videos are getting spawned upon, they will remain the same, then we can live with like a simple SQL in that case.
Perfect. And how about, can we talk something about cache? What cache are you going to use and why?
So in the cache, I think we can live with Redis. So Redis would be like a very standard application for cache that involves very low latency in terms of delivering the system things. So I think Redis would be a good option to be applicable over here.
Sounds good. Okay. On CDN, do we have anything called as cache? like that?
So CDN, it's just content delivery network, right? So it will be having its own cache. It's like a different system altogether. Just like handing it down to the third party service to be able to deliver it on the go. So yes, it will be having its own internal caches and own internal databases and things like that from which it will be fetching the things. So yeah.
Correct. Okay. Okay. And here the CDNs are also from multiple cloud providers and people. So
Yeah.
how would you go? You will create
So
your own, because Netflix and these, they have their own CDNs connected with different ISPs. They contact them, create their own CDN. How would you want to go with this?
So like I said, it depends on the kind of cost we're trying to optimize over here, right? So on the basis of that, multiple regions have multiple CDNs. So we can say maybe if we're talking at like a demography of the entire world, there's this US, there's Europe, there's Asia, then there's the Australia market and things like that. Maybe on the cloud storage as per requirement, we can decide on what kind of CDNs are we looking forward to use. So for example, Cloudflare might be giving a lesser cost in the Asia region, but some other CDN might be giving lesser storage for the US region. So we can either choose in terms of the kind of data scale we're looking at, or we can just have one single CDN, which is like maybe could be Cloudflare, and just like hand down.
I like your idea that we can have CDNs on different regions where there is cost effective. We can use the Cloudflare. If it is not that cost effective for that region, we'll create our own CDN. I can.
Yeah.
Perfect.
Yeah. So that's the part for the video uploading thing over here. One thing which I forgot to mention was the metadata part, which I think you stressed upon earlier as well. Yeah. So while the file is being uploaded to the original storage, at that point of time, the client will send a parallel request to the API server to process the metadata. Because again, we don't want it to be like a synchronous flow. It will be a completely asynchronous flow. So we can say that once the request has been sent in parallel for the metadata processing and other related activities over here, so it would basically be comprising of the data, for example, the file name, the size of it, the format of it, etc. And then the API servers update the metadata cache and the metadata database, while the other flow of the storage is being completed over here. So only when the completion handler indicates that the metadata has been processed, the completion queue is going to rectify the transcoding server. That's fine. They're done. You can go ahead and copy it down, hand it over to the S3, and then further provide it to the CDNs. So that's how the flow is going to be. Sounds good?
Sounds good. One question over here. So I have multiple users, right? So how would you make sure that a legitimate user is only uploading to my storage? Otherwise, they can overuse and like discard things here and there, right? So
right. So the authorization. Right. So authorization part comes into the play beforehand itself. What I was under the impression of that once the user has been authenticated, only then this flow comes into the picture. No. But let's say if we look at an eagle view of this, wherein like a outer world is present to which it's just a simple proxy that YouTube is asking me to upload the video, then we have to have some sort of authorization at this level.
No problem. Okay, so basically we are here assuming that the user who is able to log into system, those users only and creators only will be able to upload it, right?
Yes. Okay. And then we can use standard practices for user authorization to ensure that only legitimate users are able to do that job for us.
Sounds good. Okay. I think I'm good with the upload part. My maximum. Also, we have talked about the error handling. If the particular upload is failing, how will you handle it? Okay, I think we are good on that.
Yeah, we covered on these functionalities for
maximum
upload.
Things we are covered. Correct. Yes.
Okay. Yeah. I think we can move forward with the video streaming flow then.
Correct. Yes. Also, I would say that there's lots of metadata in the DB, right? So, will you go for any ways to how would you maintain it on a single node or on multiple nodes, sharding it, partitioning it? How would you handle that?
Right. So we can have threshold values to the metadata which is getting stored. Obviously, I'll not be taking a very distributed SQL over here initially. In case my metadata grows beyond a certain point, I would try to strive for horizontal scaling in that sense. But having said that, if we do want to do that, if we want to scale it horizontally by adding a couple of more pods to it, we can do that with basic scaling, like scaling practices by spawning new pods for it, and then start storing sequentially in terms of the SQL servers maybe, or by spawning more pods on which the SQL servers are getting hosted. So we can horizontally scale like that for the metadata part to it.
Okay, so you're going to scale the whole database instance.
Not the database instance as such. So basically scaling would imply that I would want to have one more SQL server up and ready for me on which I can start uploading my metadata information, right?
Okay, so
So
how are you like dividing your data? You are dividing it across the columns, or you're going to divide it across the rows? How?
so we can do sharding, right? We can do sharding initially for the data if it's not that much, and in case we would want to start scaling it horizontally, we can do the division on the basis of rows itself, partitioning by the rows basically.
By the roles. And
Yeah,
can you give more idea into how roles will help you divide your data?
sure. So if I talk about, let's say, the database over here, let me coin this as metadata database.
Okay,
Just a second.
no problem.
All right. So yeah, in this metadata database, what exactly are the kind of fields we're looking at? We can say that there's got to be
I'll give you all title, description, tags.
just a second, please. Title, we have
Take your time.
description, we have the tags, we have the YouTube channel across which this is getting uploaded. We could be having what else? I think that's about it, right?
That's it. We can live with this.
Right. Right. So as and when the fields start getting populated into this database, let's say I have filled probably 1 million rows in this format. So I would just want this exact same replica of this database once again. Right?
Okay. Sounds good.
So that's why the partition by rows would imply that I have just segregated.
You said rows. I heard it roles.
No, I said rows actually. So I can just partition them. No worries. You can partition them by rows and then scale it with a different database in the similar format actually.
Perfect. And how would you decide that till this much I'm going to have in instance 1 and till this much? And while searching for the database, you have 10 DBs up, suppose. How would you know that if I'm searching for this is in instance number 3?
Right. So in that case, we can like the worst case scenario would be to, of course, go and check on every database if my data is there or not. But I think a key value store beforehand would be pretty useful for us beforehand, wherein we can just store the video ID, like some sort of an identifier to be able to understand where exactly the metadata would be. So maybe like something like a zookeeper will be pretty handy for us over here, wherein we can say that the video ID could be the primary key. Along with it, we'll having a database information of which exactly database should we go forward with and where exactly will we be able to find all that relevant information.
Okay. What this zookeeper will do?
So it's a key value store, right?
Okay.
So like I said, we can be maintaining a video description. Sorry, video ID maybe as the primary key.
Okay.
Just a second.
Take your time.
Yeah. So a video ID followed by the database information.
Instance number for works.
Yeah. Instance
basically
number.
a pointer to database instance.
Yeah, that's what.
Perfect.
So with the help of this, we can identify the database and then fetch the information, whatever requires is within.
Okay.
So I would rather call it as a key value store because don't want to confuse folks in terms of zookeeper over here.
Correct.
So we can live with that.
Okay.
All right.
This sounds perfect to me now. We can go ahead with the next flow.
Sure. So let's talk about the video streaming flow then. You can scroll down. I'm just writing.
Sorry.
Yeah, video streaming flow. Okay. So let's talk about what exactly happens when you watch a video on YouTube, right? So I would say that it usually starts streaming immediately and we don't have to wait until the whole video is downloaded, obviously, because the buffering happens at the back end. And downloading simply means that the video is getting copied onto my device, while streaming means that my device continuously receives the video streams from remote sources of videos. So that's why it's like a streaming flow and not rather a watching or a simple downloading flow over there. Now, when we watch streaming videos, my client loads a little bit of data at a time, so I can watch videos immediately and continuously. So before we discuss too much into the video streaming flow, let's look at some basic important concepts of streaming protocol. So I would say this is like a standard way to control data transfer of video streaming, and some of the popular ones are I think there was some streaming over HTTP, some dynamic adaptive streaming over HTTP. So it dynamically adapts to the network rate and tries to present with what kind of stream will we be giving forward. Because if you remember, if you scroll up a little bit, you'll notice that we were transferring the S3 across CDNs with multiple different bit rates, right? Correct. So depending on that, we would want to ensure that whatever the network capacity is, on the basis of that, I should be presenting the user with that kind of stream data. Some of the other ones are Microsoft Smooth Streaming or Adobe HTTP Dynamic Streaming, HDS basically.
Perfect.
So we can work with that. Now, video streams are directly given from the CDNs. So this is basically the edge which is going to be closest to my demography region. That particular CDN will be giving me my video. So the latency is going to be extremely less in that case, right? So I can, if I draw a very, very basic flow to it, I can say that whatever my client is, it could be having, again, multiple like boxes inside this. Just trying to...
I understood that you have multiple things where client view from.
Right. So basically, it is an insulation towards using a laptop maybe, or maybe a mobile phone, or
multi-platform.
Multi-devices basically. Yeah.
Understood.
So these things will be requesting for the stream from a CDN which is closest to them.
Okay.
Right. That's like a very, very overview of what exactly is happening over here.
Okay.
If I try to dive in a little deep into what exactly might be happening over here, I can, break it down into two parts of video streaming per se. So I would say that we have to ensure we have to refine the flows with both important optimizations and introduce error handling mechanisms while streaming such videos over here. So I can say that if I talk about what exactly happens in terms of watching the video overall as such, we are just fetching the information from the CDN to understand what kind of bit rates are we talking about. So this flow, this small diagram, can be like a extended version of the top part of CDN. If you scroll up a little bit. Yes. Yeah. So I can just paste it over here.
Let's go breadth-wise rather than length-wise. Can I just copy everything to your right? Will that be okay to you?
Sure. That sounds good.
Thank you. Just give me 1 second. I'll copy everything. I'll paste so that we can have a side-by-side view of it. Works?
Yeah, that works.
Perfect. Yeah.
Right. So here, the CDN is the same CDN on which the things were getting pasted from the S3 bucket over here. Just gonna like an arrow indicating this part. And then the clients are trying to render their information onto the respective devices, depending upon whatever different bit rates there might be, right? So that's a very basic overview of how the view architecture is supposed to work in front of us. Now,
I have one question over here, if you're okay with it.
Yeah, sure.
You said that since the CDN is very close to the geographical location of your client, you will have the videos very quickly available for streaming, right?
Yeah.
Now here, I'm a user or a content creator, and I'm going to upload my video every day, very frequently. So how much latency will be there if you're going to store it at the original storage located at some very far away data center like US from India? So can you give me one solution where my uploading is also very quick compared to my, so you said that downloading, streaming is very quick. Can you give me any solution where my uploading is also very quick?
So for you, uploading is going to be very quick because it's straight up going to go to the original storage, which is your local cloud storage, right? It could be like a Google Cloud Storage or any S3 bucket. Whatever is happening in the background, that part will not be reflected to the user because it's like a background process. You can just say that I click on a upload video button and just I upload my video with an indication that this job has been done because it's in a temporary storage. Now at the back end, there's some other server which is trying to copy that information, do some sort of transcoding and all those things, which will obviously not be visible to you. So whenever the final thing...
But my problem here is that when we upload a video, right, many a times when you get the a long distance service, what happens is uploading, processing, the person has to wait. So I'm a creator, I know this happens a lot with me. So
Right.
a big video takes a real long time to upload. Until then we have to wait, and we have to make sure that system is not in a sleep mode, the network connectivity is still there, so that my data from my local is actually uploaded to that particular data center or a storage area. So any solution will be good to me if possible. Otherwise I can give you a hint around that. Can the CDN become my upload server also?
Okay. So if you're dealing with making CDN as your upload server, then there's going to be some sort of a polling mechanism on the CDN to indicate there's some activity on that CDN server, and then fetch that information, like copy that video back to some original storage,
Yes.
and from that original storage copy it back to transporting server as such.
Yes.
But I think it depends on the kind of videos length we're talking about. For example, if your video might be in GBs, then you would have to have such sort of a solution. But if the video is in lesser of the data volumes, then we can live with the keeping the original storage right next to the user overall as such.
Even that
So
is
I
cost
think
effective. Agree.
Yeah, that would
Your
be a cost
solution
effective
is cost
solution as well.
effective solution, because CDNs are costly in terms of
CDNs are costly. That's right.
I can totally
That's right.
live with this solution. I am good with this. Perfect.
Right. So we can have like a box over here indicating, if at all, depending upon the video
Oh, it will be
requirement.
optional. Yes.
Yeah, something in optional would be
No.
make sense. Cool. Sounds good.
Sounds good.
So
Yeah, please go ahead.
yeah, so basically, this is the viewing part of the client service over here. And then, of course, we'll be having a bunch of other different microservices running over here, because I think we're dealing with user analytics and then recommendations feed and all those things like that. So once the user is watching that video, we will be having some other background services running in parallel, trying to understand what kind of video is being processed. That same information also needs to be fed to these services independently. And they can start with their activities of running their own analytics maybe, or understanding that what kind of recommendations are we going to give to the user next once this video has been completely watched overall.
Understood. So you will
Yeah,
have
okay.
it in parallel way. Do we need any synchronous communication between them? Because these are two different complete systems: recommendation service and the CDNs with the user analytics. So we can do it in
Right.
parallel, right?
We can do it in parallel, absolutely. So synchronization comes into the play only. So recommendation service would not, if the user is watching a video in a full screen mode, for example, so we'll have the data from the recommendation service backend ready for us. And once the user comes out of that full screen mode, we'll have a playlist on the right side of the entire dashboard indicating that these are the next, what to watch next videos, or what could be maybe useful to you to watch next once you're done seeing this particular thing. And depending upon if the user clicks on that particular video, we can have the user analytics running in the background, indicating that this is this recommendation worked well, so the algorithm can be fine-tuned accordingly. So this is all like a daemon thread running at the background to understand the behavior of the user overall, I would say.
Sounds good to me.
Right? So there is this part. Then when we talk about, so I think we're done with multi-device support part from CDN. We're done with recommendations over here. We're done. Now let's talk about the user comments and share, subscriber, and likes.
Before that, for this solution that you have given me, can you have any space for cost optimization? One, you have given me that we can use CDNs for upload servers for speedy uploads, but you can use it only when there's a large amount of data. I can go with that cost optimization. Also here we have CDNs, and this CDN is the same here we have for the user viewers, and from here we can quickly get the data to client. But CDNs, as we said, is very costly stuff. So any solution you can give me that which video to be kept on CDN and which we can skip?
Sure. So we can have a lot of optimizations over here in terms of what videos are being copied onto the CDN. Firstly, all the trending videos are supposed to be a part of it, right?
Right.
So we can obviously work with that, and whatever is the trending content or whatever could be the breaking news, for example, if something very recently has been turned up, we'll straight away want that to be copied onto the CDNs. We can say what are the mostly recurring videos which are being watched, for example. They might not be treated as trending videos, but for example, if somebody who is studying continuously, right? So for them having videos of content, for example, code decode. Right? So code decode videos must be available for me on the CDN immediately for my rendering part of it. So we can work in terms of what kind of videos need to be present on the CDN, depending upon the user behavior for that entire demographic. So whatever user analytics we are doing over here, on the basis of this, we can even cost optimize in terms of the videos which are getting uploaded to CDNs. And on the basis of that only, we can recommend with a bias that do not copy videos unnecessarily. Just try to use the content that we have on CDN, and then they can work hand in hand in terms of user analytics over here.
So the rest
like
can
a two-way
be there
communication
on the...
between.
Correct. So the rest videos which are not that recently watched or trending videos, we can keep it on the video server, right?
Yes, we can keep them onto. Yes. We can keep them onto a separate video server altogether.
Perfect. Okay, sounds good. You can go ahead.
Right. So I can take this thing into a more algorithmic point of view in terms of understanding that how exactly is that video transcoding happening, because that is very critical to our requirement. Also, I think we are supposed to work for the user comment section and these sort of things. So we can, I think, work with this as well. Yeah. So I was saying, let's try to work for the user comments and share subscriber and likes and these kind of things as well, because I think it'll be like an important feature over here.
Correct.
So when it comes to user comments and share subscribers and all those things, I think it's more on the front of video interaction, right? So we can have like a video interaction service as a separate thing altogether running over here, which will be handling these engagements overall. So let's call it as video engagements.
Okay.
And video engagements is solely going to be interacting with the client over here with whatever video is being processed as such. So it is important for video engagements to be available to the user who's uploading the video, because as a creator, you would want to know that how folks are interacting with your video, what kind of comments are coming up, what kind of how many likes are people getting, in how much time is a person spending on what frame of the video, and so on and so forth. And for a user, it is just to see that how exactly, what are other people saying about it, right? So to gain some traction or something like that. So video engagements is an altogether separate service over here, which will in turn be focusing, like it will have its own database on which all of these analytics needs to be stored overall as such. So I think a simple SQL DB will be able to suffice for this sort of a requirement.
Okay.
Because we're dealing with comments, share button, like the number of times that was shared, maybe a simple metric of that. And yeah, a simple counter. Yeah. And the subscriber likes also could be a simple counter. So I think all these informations could be a part of this SQL DB that we're trying to maintain over here, which, just a second. Yeah, which could be again put up in this database. And of course, you will also have to keep a track of which particular video is this information for. So again, we'll have to have a video ID over here. Right. So just a second. Okay. Is there a diagram for it, the database?
Yes, we have. I'll help you just a second. SQL you need? Something like this.
I got a cylinder. I think this should work.
Yeah, cylinder will work for us, yes.
Yeah.
Okay.
So we can keep it over here, right?
Yes.
Yeah, this is okay, I guess. It should be able to interact with this part, and we can do that. And same thing.
Perfect. Sounds perfect.
Right. We can add a simple counter over here for share and the subscriber likes. The similar kind of databases will also be, of course, applicable in this context of user analytics as well, because I would say that user analytics rather depends on a lot of different metrics, and the way in which people are trying to interpret data over here, probably keeping a NoSQL would be useful as a wide column DB, because the columns are dynamically changing as such. Yes. So maybe some column based DB, maybe like MongoDB or DynamoDB or something like that would be applicable over here, because the columns are getting dynamically changed over here. So I would want to interact with the user analytics on that part. And when it comes to recommendation services overall, so this is a purely algorithmic thing, right? It needn't be storing like some very interesting information overall as such. It's like basically trying to understand the user behavior. So I think we can have an interaction of this with the, let me think for a moment. I think
I'll help you here around. So if you have a video which has n number of likes and comments, that means it's a trending video and you would recommend it more to people. So can we have this video engagement linked somewhere to the recommendation service? Can we do that?
Yeah, we could have done that, but that's not the only metric. So of course, you're absolutely right. We will have to have a engagement with this database as well.
Okay.
Yeah, we have to have an engagement. We have to have a connection with this database as well. But we also have to ensure that whatever other recommendation things are there, for example, how many times a person is clicking onto a video which is coming from a recommendation service. So that sort of information also needs to be captured somewhere, right? We cannot solely rely on how many likes or how many on the trend basically, because recommendation is a very user niche sort of a thing. So in fact, we will have to somehow maintain the on-device data which a person is trying to capture. And then there's going to be some sort of a background process running on that on-device data, which will notify some sort of my recommendation service that whatever recommendation you gave, the user clicked on that. And now maybe you can start fine-tuning the algorithm by adding a certain bias with whatever tags or whatever, emotion metric is associated with that video. So I think it's called a click-through rate from what I remember.
Okay, yes. You get click-through rate is how many times you recommend a person and they are clicking it. Yes, click-through rate.
Exactly. Yes. Exactly. So we can work with that. So another point which came into my mind was we will also have to capturing the thumbnails of videos, because these are very, very important in terms of the video engagements, right? Okay. So we have to have some sort of thumbnail data available somewhere over here. So maybe we'll need a separate database altogether for it, because it's an image, and with every image we have to have an image ID and like a video ID maybe. So we can have another blob storage involved somewhere over here, which could be again some S3 storage, which could be like a thumbnail data, like a image followed by a video ID corresponding to what kind of image are we showing for that particular video. And this I think is also supposed to be accounted for when we to deal with the video engagements. And the same thing needs to be shown to the user as well. So I would say it also has to have a link. Actually, instead of keeping it over here, I would want to keep it over here, wherein once the videos which has been uploaded onto the S3 bucket, they should also be able to populate my thumbnails. In case the user wants to provide their own thumbnails, we can live with that. Or if the thumbnails is something which is getting dynamically generated, depending upon the user number of times the user is going through a specific chunk of the video multiple times, that means that something in that frame or that segment is getting very popular. So we can put that as a recommendation to the thumbnail. Exactly. So I can say that it also has to have an interaction with the user analytics over here. Okay. So
and then finally I have over this. So simple so metadata DB is something which is already having title, description, tags, everything, right? There, while uploading itself, we have the thumbnail to be asked. Do you want the recommended thumbnail or do you want to put your own? So in the relational DB, there is some column where the file can be uploaded as a blob. So do we need a separate S3 for this?
So I think that's the same S3 on which we can work with.
But so it's a very small file. In very MBs, 1 MB, 2 MB, that's it. Why a complete separate S3?
So basically, we are dealing with a lot of videos, right? If you notice that, I think somewhere on the non-functional requirements, we mentioned that 10% of 5 million will be 500,000, sorry. So 500,000 users are uploading 300 MBs of videos every day. So we're still dealing with a lot of GBs of data overall, right? So I would want to keep it separate in terms of, like, we can even partition, I think, the original database just so that we can segregate onto the thumbnail database separately altogether. So just so that if tomorrow, right, that could be a column partition.
Correct.
And if tomorrow some new metrics comes into the play, it will become a scalable system altogether in itself. So we'll not have to touch upon the existing code and then kind of disentangle it with the video information and then enhance the system if at all required. Yes, to make it loosely coupled would be a better term over here.
Perfect. Sounds good. That solution sounds good to me. Perfect.
Yeah. So I think mostly we've covered all these
Yes.
requirements. I would want to dive deeper into the video transcoding architecture, if that's okay, or we
That is
can.
great. If you have any clue on how this has to be done, just let us know.
Hmm. Okay, so let's talk about how exactly this transcoding might be happening. And it's on the front of, there are like multiple people across the globe having different kind of devices, uploading different kind of video qualities, and they're all getting stored onto a standardized format because YouTube works on a standardized format of showing the videos, right? So we'll have to account for that factor over here as well. So when we record a video, the video file is presented in front of a certain format. Now, if we want the video to be played smoothly across other devices, it must be encoded into compatible bit rates and formats. So bitrate is basically the rate at which the bits are processed over time, and a higher bitrate generally means higher video quality. So
Perfect.
if I want to have high bitrate streams, they would require more pre-processing power and fast internet speed, right?
Perfect.
So
Right.
I think we can account for video transcoding as being important because of following reasons. The raw videos take up a lot of storage space. So we can see that if let's say there's a 1 hour long video of HD content and it's recorded at 60 frames per second. So just that much is going to take a couple of hundreds of GB of space, which we don't want to take, which we don't want it to take, sorry. Secondly, I would say many devices and browsers can only support certain types of video formats. So we have to ensure that we have to encode that specific video for all the possible formats for the compatibility reasons, obviously. And we want to ensure that users are able to watch high quality videos while maintaining a smooth playback. So it is good to deliver higher resolution to video users who have high network bandwidth and lower resolution to video who have lower bandwidth, right?
Perfect.
Then I can say that networks can change, especially on mobile devices. So we have to ensure that a video is played continuously. Auto switching of video quality should be enabled. Or in case the user manually wants to change the network conditions on the basis of that, we can also provide a user with multiple different options on that. And then this is a very common functionality because YouTube does allow to have 360 pixels, 480 pixels, and 720,
Correct.
1080, 260, and so on and so forth.
Correct.
Now, transcoding is a very interesting concept and altogether because it is a computationally expensive and time-consuming process. And besides this, like different content creators may have different video processing requirements. So, for example, some content creators require watermarks on top of their videos. Some provide thumbnail images themselves, like you said. Some has to have high definition videos, where others do not have that information. So to support this different video processing pipeline and maintain high parallelism, it is important to add some level of abstraction and let the client programmers define as to what tasks are supposed to be executed, right? So you can say that, like I was reading about a Facebook streaming video engine actually. It uses a direct acyclic graph programming model. So it
DG.
basically defines, right, it's a DAG programming model, which defines tasks in stages. So we can be delivering the entire processing in a parallel or a sequential manner, depending upon the requirement. So in our case, we will also adopt a similar DAG model to achieve flexibility and parallelism. So let's try to see what that can be. I'm going to write it down on the downside, actually, if you could come to that area.
Am I on the right front?
Yeah, this is good enough.
Okay.
Let's talk about transcoding, right? So let's say we have a original video over here.
Okay.
Just gonna zoom in a little bit. Okay, we have an original video. So primarily a video can be diversified in 3 separate categories, right? We could be having the video part to it. So I'm gonna add a video part to it. There's going to be some sort of an audio part to it. So I can have this, let's keep it over here, I would say. Audio. And there's, of course, some sort of metadata with every video which comes along. So that's the metadata part to it.
Perfect.
Metadata we've already handled, I guess, right? When we're discussing about the upload flow, there's not much to that. When it comes to audio, audio is a simple audio encoding. Not a lot of different things are supposed to be encountered for over here. So we can work with basic audio encodings. And we can finally say that once the video encoding has been done, let's assemble it to the original video which comes over here. So maybe like an assembly service comes into the picture somewhere over here.
Okay.
Let's just call it as an assemble operation. Right.
Okay.
The video part, however, is very interesting because it can be further diversified across multiple different segments. So let's try to work with them actually. Just a second. Yeah, okay. So if I split this further open, I can say that the video part, it will be having its own inspection services to understand if there's any breakage in the video or not, because raw format could be having some glitches in between them. We could be having separate video transcodings over here. Sorry.
No problem.
Yeah, video transcodings over here. We could be having multiple, for example, thumbnails could be another category to it, right? We could be having watermarks also coming across the videos. So let's say watermarks. And a lot more other things are also relevant. So we can just like put some dots to signify that information. Just gonna put this up. Like dot, 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 something like this, right?
Okay.
So all of this is nothing but a video processing task, I would say. So we can, we can put this up under video related tasks. So just gonna video related tasks. Once all these tasks are completed, I can now send this information back to my assemble area that my job is done. Now you go ahead and start collating them together to collectively make a whole video ready for me overall. So the original video, like we can see, has been split across 3 different pipelines: the audio, video, and the metadata part. Some of the tasks can be applied on a video file, which are thumbnail inspection, video transcodings, and watermarks and whatnots. And the other part could be the audio processing, which is happening independently. And then the metadata part is also happening independently. It's like we're trying to achieve parallelism in this context. So, and this video video encoding also comes into the picture because, like I said, there are multiple bit rates available. 360p, 480p, and so on and so forth. This video transcodings can further be like enhanced in terms of multiple bit rates of the videos which are coming into the picture. So I can probably add like 360p over here, followed by 480p, and different bit rates across like this. So yeah, something like this could be work. Now, I was proposing a DAG architecture, right? So this part is just trying to understand how the video is getting completely done once it has been assembled properly. Once we have assembled a video, the video transcoding architecture comes into the picture, which is what I'll be discussing about right now. So we can say that this entire task is like a pre-processing activity, which is being utilized over here overall. So I can claim that it is some sort of a pre-processor.
Okay.
Whatever video has been pre-processed has to be passed down to a directed acyclic graph scheduler. Then that particular thing is going to forward the task to no problem. This particular thing is going to forward the task to some sort of a resource manager that these specific videos are ready. Now you can choose what to do with them. And then the resource manager will further hand the task to multiple worker nodes, which will start parallelly choosing the video which has been processed and then do whatever that needs to be done ahead of it. And then we can say that the same time, preprocessor is copying down the video to a temporary storage, the one that we discussed initially, right? Good. So we have to pass down for that thing as well. Like we can say that there's a temporary storage on which we are putting down our videos.
Okay.
And the task worker is trying to read the information from that temporary storage. And once we get a notification that has been completed, that is when we get one encoded video at the end of it. So these are the 6 main components in terms of how a video transcoding architecture would look like. So the preprocessor has majorly 3 or 4 different responsibilities, which could be video splitting in terms of multiple, chunk or frames, right, group of pictures basically. And second thing could be some video splitting would also be accounting for the fact that some older device might not be able to support the video. So we
Right.
have to account for the devices that it should be compatible in terms of the operating system it is holding down to, or what kind of different requirements older device might be needing.
Okay.
Then we have the DAG generation thing. Like the preprocessor generates a DAG on the configuration of on the configuration files, I would say, which the client programmers write. So, for example, if I'm talking about a task of how it would look like, I can claim that my task is supposed to be like indicating what kind of name. It could be a download task, for example. Let's say download input. It could be having a type to it, that what are we doing with that type of the task. It could be having an input that maybe like a URL, I would say, which is supposed to be downloaded from the CDN. So config.url, and then what the output is supposed to be. So I can say that some sort of iteration in terms of config dot output is equals to it.file maybe. And then, of course, what are the next steps associated with that? Could be like transcoding the video, or whatever the task needs to do. Basically, we can pass down some sort of information over here. And then when we talk about the DAG scheduler, which is the second component of this transcoding thing, you can say that the raw level diagram that we have drawn, if you could scroll a little bit up, which is basically transferring it into, first of all, splitting into audio, video, and metadata section, and further staging it down. So the directed acyclic graph could be an implication that this is my stage one of splitting it into audio, video, and metadata respectively. And then the stage two could be the video encoding and then thumbnail processing and your audio encoding part altogether. So I would rather coin this part as stage one and this part as stage two.
Okay.
Right? And then the resource manager responsible for managing the efficiency of resource allocation. So it could be containing message queues in terms of, task queues in terms of if there is any priority which is supposed to be given to a video. If there is some sort of, if a particular task needs to be processed before the other task. So whatever kind of priorities we're dealing about, that part will be taken care of my resource manager. And it will be subsequently adding the task to maybe a task queue or a worker queue or a running queue or a priority queue, depending upon what is the priority we're looking at. And finally, those task worker will be reading the information from the queue, which is getting populated by my resource manager. And once that part has been done, the task worker is just going to probably add a watermark or add some sort of a thumbnail or merge videos or encode videos. And finally, it will render the encoded video back to us. So that's the overall flow I'm looking at.
This sounds perfect. This sounds great to me. I think here you have actually covered everything I think we have written around for. Auto scalability, I've already said that we can have these servers as auto scalable instances in our cloud provider itself, right?
Right. So we can make use of something like a Kubernetes event-driven architecture, KEDA, basically, which uses the auto scaling part whenever it's required to spawn more pods, depending upon the traffic we're looking at. And because it's an event-driven architecture, so automatically when we see a lot more traffic coming in altogether, it will try to auto scale the pods by spawning multiple pods and then put them into a service registry, which will further be read by a load balancer. So in case some new traffic come into the picture, we can redirect onto the new pod which has been spawned very recently for us. So we can do something like that.
Okay. Also for the cost optimizations, also one thing I was missing that was slipped in my mind. There can be multiple videos which are region specific. So we can also have those videos which are completely region specific in those particular CDNs only. Why to put it in different
locations? So if I Absolutely right. So I think we can talk in terms of the speed optimizations over here a little bit.
Yeah, right.
So we can say that another way to improve speed is by setting up multiple upload centers across the globe. I think I was
Okay.
kind of inspired by the idea which you have put up initially for having a CDN for the user to upload a video. So we can say that if I try to look at a world map, maybe just gonna do a very rough architecture over here.
No
So
problem.
if this is like America, we're looking at Asia, we're looking at uh, Australia, maybe somewhere over here,
Okay.
and let's say North South America, somewhere over here. Yeah, anyway, so basically multiple regions across the world will be having their own independent upload servers. And the benefit of that is going to be that it's allowing users in those specific regions to only interact with their region specific CDN servers when it comes to uploading videos, of course.
Perfect.
So when they do that, it will just straight away go to the local CDN server as an upload center,
Yes.
and then this will allow them to have lesser time to upload the video,
Latency.
and it will also it will also apply for it will also promote having parallelism everywhere. So the end goal is to achieve low latency at the end of it. So I would say that because it's a very loosely coupled system altogether, having its own independent CDN caches, we can have completely different users across different parts of the globe uploading videos at the same time. And then whenever these CDNs are getting populated with the respective videos, we could be having like background servers trying to fetch the information from the CDN servers into them. And then you could be having like a download module, which would further be copying down the CDN videos to some sort of a data center, which is what we were coining as our original storage in the first diagram we had created, right?
Perfect.
Another thing what I can think of is to have in the original storage, when we are trying to download the video into the transcoding server, we could be putting some message queues up over there. Because when message queues are introduced, the encoding module does not need to wait for the output of the download module anymore. We can just straight up say that the video is ready, put it up into a message queue, and then the further download module will further put it up into a message queue, which will be read by a encoding module altogether. So we can make use of message queues in between the two downloading and uploading server links overall, I would say.
Sounds good.
Also, I think we also have to account for the fact that it's a cross-region application. So we have to be very, very careful in terms of adhering to the privacy policy laws of the different regions. So when we're trying to pass down a video to a CDN, we have to ensure that it's in line with the policies governed by the specific region. And we cannot be putting up videos which might be of explicit content or not to be viewed in that particular region. So we have to account for the safety optimization, like a pre-signed URL, from which we can fetch the data information. So that's also something we have to be accounting for over here.
Perfect. That's the privacy that you're maintaining with your videos, that is uploading and downloading here and there.
That's right.
Perfect. I think pretty much we've covered everything we can have here, right?
Yeah.
Yes, we have pretty much covered everything. Eventually, consistency is also something you have done already, told me. I think I'm pretty much good with this, Akshat. Anything else you need to add to this? I think this is the pretty much everything we can have about the discussion on the YouTube front.
I think we have discovered almost every module in detail, which is like a good discussion overall.
Perfect.
Cool.
Perfect. That's it, Akshat. This was such a nice mock interview. This shows that you are really prepared very well. And is there any way community can reach out to you and seek some help from you on how did you prepare such a nice system design concepts? Is there any platform where you are available or how people connect with you?
Sure. So first of all, I would like to thank you so much, you and the entire team at Decode, to giving me this opportunity to interact with all your folks. Thank you for taking out time to do this mock interview. And to answer the second question, yes, I did read a lot of articles, a lot of blogs, a lot of YouTube videos. And if in case anybody wants to connect with me personally and have a word about what exactly do I do, how have I learned these things in general from scratch and worked on them as a first-hand application development, I would love to connect with you on this platform known as Engine Bogey. So Engine Bogey helps people unlock their potential with expert mentorship, If you could click on Find Experts button on the top right, you will be able to see a variety of people listed down on this platform, as high as engineering leaders at Hotstar and senior development engineers at Google and Amazon, etc. You can just choose any of the candidates as per your own convenience and decide to have a session with them. Some of the sessions are free, of course, some of the sessions are paid. And as per what is your requirement, you can definitely go ahead and click on the profile of independent contributors and have a word regarding what exactly is the need, which is going to help you unlock that potential for you. So if you notice, I also have signed up on the same platform. Feel free to definitely click on my profile and reach out to me in case you folks want to have a one-to-one mentorship, or maybe if you want to study a particular topic, or if you want a complete end-to-end solution in your DSA, HLD, or LLD journey.
Perfect. So this sounds really good, Akshat, because it's very difficult to switch from service-based to product-based. So having help like you will be very helpful to community, because always you need a help. So thank you so much for giving a way how we can connect with you. Thank you so much, Akshat, for such a knowledgeable content you have shared with the community. This means a lot, and I think you're very well prepared with the system design fund, because this is something which I've given you on the go and you are able to design it really nice. So any more questions from you have for me?
No, that was really insightful, and thank you so much for taking our time to do this. It was really fun. And yeah, YouTube is actually a very read heavy systems, right? So it was really fun to interact in terms of how it will be scaling and serving so many users. So like a very truly engineering marvel, I would say.
Yeah,
it was good to discuss that.
Thank you so much for everything, man. This contribution to community will actually be remembered for long. Thank you so much.
All right. Thank you so much for taking out time to do that, Yashi. All right.
Thank you so much, Akshat. This was such an insightful session. Thank you so much for sharing your knowledge and preparation with the community. Also, if you guys want to be a part of this mock interview series and share this with the community, just add your details in the form given in the description, and we will reach out to you as soon as possible. Thank you.